Hey everyone. Yes, you read the title right. I'm going to relate machine learning to cooking. Doesn't seem like those two are related though, does it? So in this video, we'll go over the machine learning process and then relate each of those steps to the cooking process. So when creating machine learning models, it's important to follow the machine learning process in order to get the best performing model that you can into production and to keep it performing well. But why relate machine learning to cooking? Well, first, I really enjoy cooking, but also it is something we all do. Now, we all don't make 5-course meals every day or aim to be a Michelin star chef, but we do follow a process to make our food, even if it may be just to heat it up in the microwave. So for the machine learning process, here's a diagram that's known as the Cross-Industry Standard Process for Data Mining, or simply known as CRISP-DM. Now let's go through this diagram real quick, and then we'll relate each step to cooking. So first we have business understanding, and that is what exactly is the problem we're trying to solve with our data. After that is the data understanding, which is what exactly is in our data, such as what does each column mean and how does it relate to the business problem. Then we have data prep, which is the data pre-processing and preparation, and this can also include the feature engineering that goes into the data. We got modeling, which is actually getting a model from our data. Then we have evaluation, where we evaluate the model for performance on generalized data. And then deployment, where we deploy the model for production use. Now you may have to go through multiple integrations of getting a better understanding of the business problem and the data, doing the data prep and modeling, and even going back to business problem when evaluating the model. And you may also have to go back to understanding the problem once the model is deployed. Now, but before we continue, there are a couple of items I would like to add to help improve this process. First, we need to think about getting our data. And getting data can either be before or after defining the business problem. Sometimes you may have the data already and define the business problem, but you may also have to get the data after defining the problem. Either way though, we need to get good data. And you may have heard an old saying in programming, garbage in, garbage out, and that applies to machine learning as well. I will also add a separate item in the process for improving or optimizing our model. So once we have an algorithm, we can spend some time to improve it even further. Alright, so now that we understand the machine learning process a little bit better, let's see how it relates to cooking. And at first glance, you may not see how the machine learning process relates to cooking at all, but there are more similarities to it than you may see at first. So let's start with the business understanding. For cooking, we may want to make something, but what exactly? What do we want to accomplish with it? Is it for breakfast, lunch, or dinner? Is it something just for yourself, or do you want to create something for a family of 4, or maybe something for a large gathering? Next, let's go into the first item I'd like to insert into the process, getting data. This can be related to getting your ingredients. Now, you may already have the ingredients that you need, or you may need to go to the grocery store to get them. In order to improve our dish that we're making, we would need to give it the best ingredients that we can find. Now, you wouldn't want to give your model bad data, just like you wouldn't want to use spoiled or rotten ingredients when making your food. Now, data processing is probably the most important step after getting good data. For cooking, this is equivalent to preparing your ingredients. This includes chopping any ingredients such as vegetables, but keeping a consistent size when chopping also counts. And this helps the pieces cook evenly. So if some pieces are small, they can burn, or if some pieces are bigger, then they might not be fully cooked. And just like in machine learning, there are multiple ways to process your data. There are also different ways to prepare ingredients. In fact, there's a word for processing all of your ingredients before you start cooking, mise en place, which is French for everything in its place. And this is done in cooking shows all the time where you have everything ready to start cooking. And this actually makes sense for machine learning. We have to have all of our data pre-processing done on the training data before we can give it to the machine learning algorithm. Now it's time for the actual modeling part of the process, where we give our data to an algorithm. In cooking, this is actually where we cook our dish. In fact, we can relate choosing a recipe to choosing a machine learning algorithm. The recipe will take the ingredients and turn out a dish, and the algorithm will take the data and turn out a model. And different recipes will turn out different dishes. Take a salad, for instance. Depending on the recipe and the ingredients, the salad can turn out to be bright and citrusy, like this kale citrus salad, or it can be warm and savory, like this spinach salad with bacon dressing. Now they're both salads, but they also turn into different kinds of salads because of different ingredients and recipes. So in machine learning, you can have different models from different data and algorithms. And depending on the algorithm, the machine learning model is using different parameters that can optimize the model for better performance. These parameters are called hyperparameters, which is used during the learning process of the model to your data. And this can be updated manually by you choosing values for the hyperparameters. There also are ways that this can be automated. But how do we optimize a dish though? Perhaps the best way to get the best taste out of your dish, other than using the best ingredients, is to season it, specifically seasoning with salt. Now, in this video by Ethan Klabowski, he suggests,
I would argue that the majority of home cooks severely undersalt the food that they are cooking, and it's often the #1 culprit of why the food doesn't taste as good as you think it should.
And he even quotes this line from the Ruhlman's 20 book.
This is also a common reason why respected chefs will say the #1 skill for a cook to learn is how to properly salt their food.
And I've even experienced this in my own cooking, where I don't seem to add enough salt. But once I do, the dish tastes basically 100 times better. And adding salt to your dish is the more manual way of optimizing it with seasoning. But is there a way that this can be automated? Actually, I think there is. So instead of using just salt and adding other spices to the dish yourself, you can get these seasoning blends that has all the spices in it for you. Alright, now evaluating the model is going to be one of the most important steps, because this tells you how well your model will perform on new data, or rather, data that it hasn't seen before. And evaluating your cooked dish is a lot more fun. This is where you get to eat it. And here you will determine if it's a good dish by how it tastes. Is it good or bad? If you served it to others, what do they think about it? And then we have iterating on the model, which is a part of the process that may not seem necessary, but it can be an important one as well. Your data may change over time, which would then make your model stale. And that is, it's relying on data that it used to, but due to some process change or something similar, it no longer does. And since the underlying data changed, the model won't predict as well as it did. And how can you iterate on a dish that you just prepared? First thing is if it was good or bad. If it was bad, then we can revisit the recipe and see if we did anything wrong, or maybe we overcooked it, or missed an ingredient, or maybe we prepared an ingredient incorrectly. If it was good though, we can still iterate on it. Any ingredients you would like to add or remove to make it more to your liking? And a lot of chefs and home cooks like to take notes about recipes that they have made. They write in some tricks they learned while they were making it, but also some different paths from the recipe that they either had to take due to a missing ingredient or that they preferred to take. Alright, so hopefully this helps you better understanding of the machine learning process through the eyes of cooking a dish. It may even help you understand the importance of each step, because in cooking, if one step is missed, then you probably won't be having a good dinner tonight. Oh, and if you're wondering where does AutoML fit into all of this, then you can think of it as the meal delivery kits like HelloFresh or Blue Apron. They do a lot of the work for you, and you just have to put it all together. So thanks for watching, and I hope you enjoyed the video.